This video is going to be for the heat diffusion of ice lab. So I've got some ice, I've got some warm water, and I've got a coffee cup calorimeter. Our goal in this lab is to figure out the heat diffusion of ice, which is how much energy it takes to melt 1 mole of ice, to change it from a solid to a liquid. All right, and so to get started on this lab, what we need to do is we need to get a bit of warm water into our calorimeter. So I've got some warm water. I'm going to pour some water in. It doesn't matter exactly how much. It doesn't matter exactly the starting temperature of it. But it is important that I record the mass of the water. So the mass of the water is 111.6 grams. We got 111.6 grams of warm water. And the temperature of that warm water, give it a second here. I'll record the temperature of the water. So the temperature of water looks like it is about 85.9 degrees. 85.9 is the initial temperature of your water. All right, and so what we're going to do is we're going to take some ice cubes and start adding them to the hot water. And the ice cubes will melt. And as the ice cubes melt, the water that was originally hot is going to be getting colder. So I'm just taking ice cubes and dropping them in, and they're melting pretty rapidly. As those are melting, we're going to see that the temperature of that warm water is going down. So we're down to 44 degrees. It's continuing to drop, and I'm going to continue adding a little bit more ice to it. And so I'm just going to keep adding ice until the ice stops melting, and the final temperature should get down close to 0 degrees Celsius. So we're down into the 20s. As the water is cooling and as the ice is melting, I'm going to add a few more. As that's melting, we can take a look at the heating curve right here, and we'll talk about the calculations and what's going on. We're starting with some ice, which we're assuming is at 0 degrees. So the ice is starting right here. And then we're starting with our hot water, which was 80-something degrees. And so the water is getting cooler, and the ice is melting. Right? So the water started up here and it's cooling and the ice is melting. And since we're in an insulated container here, no heat is exchanged with the rest of the room, we're assuming. Then the amount of heat lost by this water should be equal to the amount gained by the ice. And so when you do your calculations, you're going to use this equation. Q is equal to delta T times mass times specific heat for the water that's cooling from its initial to final temperature. It's going to be decreasing the mass of the water. We recorded that at the beginning, and you know the specific heat of water is 4.18 joules per gram degree Celsius. That amount of energy that the hot water lost is going to be equal to, but with the opposite sign, as the energy absorbed by the ice. And so this is the equation to figure out how much heat was absorbed by the ice. It's going to be equal to the number of moles times the heat of fusion. And so we're going to try to find the heat of fusion of ice, this number right here. And so you're going to solve for that, and let's see how our ice is doing. So all the ice is melted. I'm going to add a couple more pieces of ice here. Try to get it as cold as we can. The closer we get to 0, the better result we're going to get. All right, so this looks pretty good. We got down to 2.5 degrees. I'm just going to scoop out any of the ice that didn't melt. So there's a few pieces of ice that didn't melt. I'm going to get rid of those. Since they didn't melt, they don't need to be included in our calculation. So now all the ice is melted. We're at 2.4 degrees Celsius is our final temperature of the water. Now I'm going to put this back on the balance, and we're going to find the final mass. So the mass right now is 235.1 grams. And so we're going to use that and the mass of just the hot water at the beginning The difference between those is how much ice that I added. So I wasn't weighing the ice as I added it. I'm just weighing it here at the end. And then you can subtract the initial mass, or subtract the initial mass from this final mass to see how much ice was added. And so that'll be the mass of the ice. So that should be all the data that you need. You've got the temperature change of the hot water. You know the mass of the hot water. We measured those at the beginning. The specific heat of water is 4.18 joules per gram degree Celsius. The amount of heat that was lost by the hot water has to be equal to the amount gained by the ice, absorbed by the ice, in order for that phase change to take place. And so that amount of heat is going to be equal to the number of moles of ice. So you're going to get the mass of the ice and change that to moles. And then you're going to solve for the heat of fusion of ice, which should be measured in kilojoules per mole.